So here we are given this problem. You are given a professional robber. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken. If two adjacent houses were broken on the same night. So, given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So here we are given these values, and we can't rob two adjacent houses. Like two adjacent houses are like 2 and 3 and 1 and 2 and so on, 3 and 1. So like we can't rob two adjacent houses. So, and we need to maximize the total. So like which are those houses which aren't adjacent are 1 and 3 and 2 and 1. So 2 and 1 will give you 3 and 3 and 1 will give you 4. So the maximum total here is 4. So like it's 4, and here it's 2, 7, 9, 3, 1. So here adjacent houses are 2, 9 and 7, 3, 1. 2, 9 and 1 and 7, 3. So 7 and 3 will give you 10, and 2, 9 and 1 will give you 12. So the maximum money you can rob here is 12. It's like you can see, like you're covering all possible cases over here. So the ideal solution here can be a DP solution, and you can check the constraints too, like for determining the time complexity of the solution. The time complexity would be in between O of n cube and O of n square. So it's better to be less than O of n square. So the idea behind this question is like you can either drop the houses or not drop the houses without alerting the police. So the two cases over here would be dp of I0 where you drop the houses, and dp of I1 where you don't drop the houses. So first let me define it like this: nums dot size, and define our dp vector of vector. It's always better like to take this as this: dp of n vector n vector n Now I will write the states over here. The states over here is dp of I0, meaning maximum sum you can get from 0th house till I minus 1th house, I minus 1th house, such that you pick the ith house, and dp of I maximum sum same, but like here you don't pick. The only difference here is you don't pick. Don't pick it. Okay, and pick. And like in DP, first it's always like base case comes first, then it's the transition equation, and then it's always the final sub problem, which is always asked in the question. Base case is where your transition equation fails. So like it's always better to like first predict the transitions. So like the transitions I can determine by taking this, or int I equals to 0, I greater than n, I plus plus. I can write the transition equation as dp of I comma 0 being max of dp I minus 1 till 0 when you pick the house, and when you don't pick the house. And another case is dp of I comma 1 the value here would be array of I plus you don't pick dp of I minus 1, you pick them at last. Here it's nums of, so here we can write nums. And like if you put values in this, so you'll get dp of I minus 1, and like if you put the values over here, dp of 0 comma 0, like if you take the value 0 comma 0, so you'll get the case like you'll take the maximum value of dp of minus 1 comma 0 and minus 1 and minus 1 and 1, and these states are not defined. Similarly over here, if you take 0, then you will get nums of 0 only, and here it would be minus 1. So the base cases, we will get two basis cases over here. One base cases is when dp of 0 and 0 equals to 0, and dp of 0 comma 1 would be nums of 0. Over there. And the final subproblem that this question is asking is return the maximum. It's like this: return maximum of dp n minus 1 0. So let's see, and hopefully it will work. Okay, so what's wrong over here? Comma 1 0, I should take 1 because it fell over here. dp of I comma 1 should work, I think. Mm, it's working over here. So here's the solution, and when I submit it, it will work.